A simple random sample of adults are classified and their level by sex and their level of education. A person is selected at random from this group. What's the probability that the person is a male given that the person has a secondary education? So when something is given, then that becomes our whole universe, our whole total. So we're given that the person has secondary education, and the secondary education is represented by the second row over here. The second row represents the secondary education. And that's the total here is 85 plus 70. That's 155. So question is to find the probability the person is a male. And among these 155, we have 70 males. So it'd be 70 out of 155. And we have to simplify this fraction. So this one simplifies into 514 times and 531 times. So as we said, since it was given that the secondary education, so the secondary education became our whole world, 155, and we pretend as if the other things don't even exist. So 14 out of 31. What's the probability that the person does not have a college degree given that the person is female? So now we are given that the person is female, so the females become the whole world now. 110 plus 85 plus 55. So that's 250. That's our grand total now. And we have to find the probability that the person does not have a college degree. So again, this is the only world we have, the world of females now. And among them, the ones that do not have a college degree are these two, the 110 and the 85. So the elementary and the secondary. So it'll be 110 plus 85. These are the ones that do not have a college degree. The total is 250. So that's 195 out of 250. And now 539 times is 195 and 550 times. So it's 39 out of 50. In an experiment, okay, so let's see. What's the probability that the person is experiencing hypertension given that the person is a heavy smoker? So this is very similar. So now heavy smokers is our whole world, the 29 plus 11. And among them, 29 have hypertension. So it'll be 29 divided by 29 plus 11. So that's 40. 40 is a grand total in this case. And what's the probability having non-smoker given that the person is experiencing no hypertension? So no hypertension is this part. So 46 plus 30 plus 11 is 87. That's no hypertension. And we have to find the probability that the person is a non-smoker. So among these non-hypertension people, we have 46 non-smokers. So 46 out of 87. In this problem, the word given isn't present, but we have this if the oil has to be changed and if a new filter is needed. So the if will serve the purpose of given. But we're not given information in a tabulated form as we were in the problems before. So here we can also use the formula for conditional. So let's first add a page, insert pages. blank page. So in this case, we may also use the conditional formula, which says that probability of A given B is equal to probability of A and B, which we know can be written as PAB, divided by probability B. So a common symbol for A given B is A, this vertical line B, that means A given B. So that's probability AB divided by probability B. Okay, so in this case, the probability automobile being filled with gasoline also needs an oil change is 0.2. So we are told that probability, so we are given that the automobile is filled with gasoline. We're not having the word given explicitly, but if you see what's going on, it's saying that we're given that it's filled with gasoline, and the probability that if it's filled with gasoline and also needs oil change is 0.2. So let's say probability oil change given gasoline, so O given G, that probability is given to be 0.2. The probability it needs oil filter is zero point 0.4. So probability, let's say, of filter is 0.4. And the probability that both the oil and the filter need changing, so probability oil and filter, so OF, that probability is 0.16. And then they say, if the oil filter has to be changed, what's the probability that if the oil has to be changed, what's the probability that a new filter is needed? So new filter is F. So probability F given oil has to be changed. So oil change we are representing by O. So in fact, we can even summarize these letters. So O means needs oil change. F means that it needs new filter. So this O given it seems that the vehicles that are being considered here are the ones that are being filled with gasoline. So we could just have mention this is just O, because all the vehicles that are being considered are filled with gasoline. So in this particular problem, gasoline is not really playing a part. So probability needing oil change is the same as needing oil change given that it's being filled with gasoline. So this is just P of O for practical purposes. So we have P of O as 0.2, we have P of F as 0.4, and we have P of OF as 0.16. And we have to find probability new filter given oil change. So that has to be found out. So now if we use our A given B formula, probability A given B is probability AB divided by probability B. So probability F given O equals probability F and O divided by probability O. So filter and oil change. So now that's the same as OF, because OF says it needs oil change and new filter, and FO says that it needs new filter and oil change. So in an and, if there's an and between two things, you can just reverse the order and nothing changes. So probability FO is 0.16. Probability of O is 0.2. So 0.16 divided by 0.12 is 0.8. So this one is 0.8. Probability that the oil needs to be changed. So probability, okay. Well, this is not well worded because they have a different B over here and they have a different B over here. And what they're really answering is the original B. Original B is saying if a new filter is needed, what's the probability that the oil has to be changed? So what they're really asking is, that if a new filter is needed, so if, as I said, if means given, what's the probability that it needs oil changed? So we have to find probability O given F, because if is the same as given. Because if a new filter is needed, which means we're given that a new filter is needed, what's the probability that oil has to be changed? So we have to find probability O given F. So O given F would be probability of O and F divided by probability of F, because according to the formula, whenever you have A given B, you have probability AB at the top, and whatever is given, you have in the bottom. So if it's A given B, you have P of B in the bottom. If it's O given F, you will have P of F in the bottom. So P of OF was that it needs both the changes. So that was simply, let's see, P of OF was 0.16, and we have to divide by probability F of F, which is 0.4. We didn't use that in part A. So OF is 0.16 and F is 0.4. OF is 0.16 and F is 0.4. And that comes out to be 0.4. Okay.